Well, thank you very much for the opportunity to talk to you today about the role that managed forests can play in meeting the net zero challenge. This is a cut down version of the presentation I gave at the conference. Hopefully I've cut it down enough to fit in your time frame. Does mean that I have to skip over a few slides pretty fast, so apologies in advance for that. I'm going to start with a summary of the international policy context that's creating the opportunities for managed forests, and then I'll talk about the ways managed forests can contribute to net zero, and I'll finish up talking about the relevant international and local initiatives at the government and industry level. So the key policy driving the net zero ambitions is the UNFCCC, the Framework Convention on Climate Change, and the current focus of the UNFCCC is the Paris Agreement, the historical agreement that was reached between world leaders in 2015. The wonderful thing about the Paris Agreement is that we now have all nations on board with targets. Previously, under the Kyoto Protocol, it was just the developed countries that had targets for emissions reduction. And the Paris Agreement has declared a target of limiting warming to well below 2 degrees, preferably only 1.5 degrees. And the Paris Agreement is where we get the interest in net zero, because the Paris Agreement states that in order to meet that climate target, the world will need to balance emissions with removals, that is carbon sequestration, in the second half of the century. Just a little note in parentheses, you'll often hear it said that the Paris Agreement says we need to do this by 2050. It doesn't actually specify 2050, it just specifies second half of the century, because there are a number of pathways to get there. In order to bring all countries on board, it had to be more flexible than the Kyoto Protocol. So it's actually now a situation where countries determine their own contributions, the so-called nationally determined contributions, but they all have to use the same methodology to measure and demonstrate their progress towards them. The UNFCCC is guided by the Intergovernmental Panel on Climate Change, the IPCC, which is a panel of thousands of scientists who review and synthesize the scientific literature to provide guidance to the UNFCCC. And last August, the IPCC released the first volume of their 6th assessment report. Volume 1 focuses on the evidence and physical impacts of climate change. And incidentally, volumes 2 and 3 are about to come out. The IPCC Bureau is currently deliberating on volume 2, which is about adaptation, and they'll start looking at volume 3, which I'm an author on, later in March, but should be released by the end of March. So what the 6th assessment report showed us was actually no surprise. Human activities are already causing warming on the planet by about, on average, 1 degree. On Australia, it's 1.4 degrees. And each of the past 4 decades has been the warmest on record sequentially since pre-industrial times. They've determined that there's over 50% chance that we'll cross that threshold for 1.5 degrees warming in the early 2030s. That's not necessarily a disaster. Many of the pathways to meeting 1.5 degrees involve crossing the threshold and then pulling CO2 back out of the atmosphere to make up for that overshoot. But certainly the report says that unless there are immediate, rapid and large-scale emissions reductions, limiting warming to 1.5 degrees will be beyond reach. I'm sure you're all aware of the impacts that climate change is having already and will continue to have if we don't succeed in reining in our emissions. It's obviously a threat to all human and natural systems, but particularly in Australia and particularly for our agriculture and forestry. One thing that the first volume of the 6th assessment report really stresses is that there's essentially a linear relationship between the amount of global warming and the amount of CO2 in the atmosphere. So what this means is the most important mitigation action is to reduce CO2 emissions. And there are several ways that managed forests can contribute to reducing emissions. The first one is when we use wood products in place of greenhouse gas intensive building products, concrete, steel and aluminium. Global meta-analysis found that on average, each tonne of carbon in wood products displaces about 2 tonnes of emissions. This does, of course, vary depending on what products we're talking about. We do, of course, also have to make sure we're comparing apples with apples. So we'd be comparing a timber wall frame versus a steel wall frame rather than 1 kilo of wood versus 1 kilo of steel. The second way that managed forests can contribute to reducing emissions is producing biomass for bioenergy that's used in place of fossil fuels. Bioenergy is essentially a carbon neutral energy source as long as the biomass is regrown after it's combusted. And that is, I've written mostly because that's apart from any fossil fuels that are used along the supply chain. Bioenergy is an overlooked resource in Australia, and certainly other parts of the world are much more in tune to the opportunities from bioenergy. Some of the great things about bioenergy are that it's available now. We don't have to make major modifications in order to use bioenergy. We can fire wood chips in coal-fired power stations. We can use biodiesel. We can use ethanol in our current engines. So we don't need major infrastructure changes in order to start using bioenergy and displacing fossil fuels. The benefits of it are that it's storable and dispatchable, unlike the intermittent renewables, wind and solar, and it can provide a range of other environmental and social benefits, such as jobs in the bush. And although we always think about, well, the rest of Australia anyway, thinks about solar and wind when they think about renewables, as I said, bioenergy really could play an important role in transformation of energy sector towards 100% renewables. In particular, because it has this quality of being dispatchable and storable, it can play a strategic role in stabilising the grid as we expand wind and solar. So we hear that we have to have new gas-fired power stations in order to provide that stability, but in fact bioenergy could provide that stability. And this is a nice study published by Mengyu Li at Sydney Uni, and she showed how if you have a small amount of bioenergy in the mix, the bioenergy is in the green, and this is for some days in winter when the solar and wind resources are low. And if you have some bioenergy in the mix to make up for those low amounts of solar and wind being generated, then you can reduce the overall cost of electricity because you don't need to have all that spare installed capacity for wind and solar for those sort of days. There's some nice statements the IPCC has made over the years that the foresters enjoy a lot. Unfortunately, they seem to be overlooked by many policymakers and many scientists and much of the community. But what these statements say, that is, if you compare production forests with conservation forests from a whole system perspective, you generally find that a forest managed for timber plus bioenergy makes a greater contribution to climate change mitigation than a forest left unharvested to sequester carbon alone. This was first stated in the 4th assessment report in 2007, and then it was reiterated again in the special report on climate change and land in 2019. And this is an example precisely showing this. It's a study that was led by Fabiano Ximenez from New South Wales DPI now, where he contrasted the climate effects of continuing to harvest New South Wales native forests versus ceasing harvesting. So the ceasing harvesting option is shown in the black line. The green is the carbon stored in the forests. We're also looking at the carbon stored in products and in landfill, so end-of-life products going to landfill, and the benefits of displacement plus displacement of products plus displacing fossil fuels through using biomass for bioenergy. And in the longer term, at least, the managed forest scenario gives greater mitigation benefits. Of course, we do need to acknowledge that climate is not the only environmental objective, and we have to think about managing our resources to meet various objectives. And so there's a lot of objection to the possibility of using native forest biomass, even when we're talking about residues for bioenergy, because people are concerned about the biodiversity implications, etc. So we do need to acknowledge these trade-offs, and we need to, I guess, accept that there are trade-offs with pretty much everything that humans do on the planet. And what we need is good governance processes that balance the multiple objectives. So coming back to the Paris Agreement, I've talked about the fact that there are ways that managed forests can contribute to reducing emissions, but in order to get to net zero, we also need to take CO2 out of the atmosphere. And there are many ways that forests can contribute there. The first one's very obvious, reforestation of unforested land. When you plant trees, they grow, they take CO2 out the atmosphere and store it in their wood. The second one is if you take that biomass and then you combust it in something equivalent to our current coal-fired. So you've got the carbon coming from the atmosphere instead of fossil sources. You've got it being combusted in a power station. You capture the flue gases and then you condense them and you pump them underground. You do geosequestration basically. So this is a negative emissions technology, a way of taking carbon out of the atmosphere and storing it underground. Another obvious one is managing to increase soil carbon levels. If you increase soil carbon, you're sequestering carbon, and you're increasing organic matter. That's always a good thing. Every backyard gardener knows the benefits to productivity of increasing soil organic matter. Generally here, you're talking about practices that increase the amount of biomass going in and reduce the rate of turnover. So things like stubble retention and zero tillage, cover crops, etc. One you might not be so familiar with is biochar. Biochar essentially means taking biomass and heating it in a low oxygen environment and creating charcoal. It looks essentially like charcoal. It is essentially like charcoal. But when we say biochar, we're talking about a char that's manufactured in a controlled condition that doesn't release smoke and CO2 and methane, and then using that product, that charcoal, as a soil amendment, which might sound a little strange, but 100 years ago, some German scientists looking in the Amazon found that there are some really fertile soils there that are enriched with charcoal due to the practices of the indigenous people there hundreds and thousands of years ago. And they wondered if you could create the same fertility by making new charcoal and putting it in the soil. So people have been researching this for the last 20 years. It's a fairly new research topic, and people have been making biochar at all sorts of scales, from little cook stoves through to plants that process a couple of tonnes per hour. You can do it also even in just a hole in the ground, as long as it's made the right shape and managed the right way. And what we found, I should mention that in fact, New South Wales DPI is one of the pioneers in biochar research, and we have the longest running field trial on biochar in the world. And we did some of the very earliest work looking at biochar stability. We found that new charcoal put in the ground certainly is very stable. We also found it has it can increase yields. It really depends on what you make the char from and what feedstocks, what temperature, and where you apply it. It tends, on average, to give increases in yields of 10 to 40%, especially if you're applying it in tropical, acidic, or low fertility soils. It has a liming effect because it's usually alkaline. An interesting finding was that it reduces nitrous oxide emissions from the soil. So soils naturally produce nitrous oxide as nitrogen from fertilizer or decomposing residues is metabolized by the bugs in the soil. And nitrous oxide is nearly 300 times worse than CO2 as a greenhouse gas. And what we found was we got quite dramatic reductions in nitrous oxide, up to 50% in some cases, although this is quite variable and we need to understand more about it before we can be sure what circumstances we'll be able to reproduce that. It also has useful properties when it comes to contaminated soils. It absorbs heavy metals and reduces the availability so they're not taken up by plants. And if you put a lot on, it can reduce the soil strength and so reduce the amount of fuel you need to put a plough through the soil, for example. And it increases the water and nutrient holding capacity of the soil. So that might all sound a bit too good to be true. Those benefits don't all happen for all chars in all circumstances because they do vary, as I said, depending on the feedstock and the production conditions. Some of the other ways that people are talking about and actually starting to apply for taking CO2 out of the atmosphere might sound a bit more fanciful. This thing called direct air capture is a process whereby you have fans that pull air across a filter that extracts the CO2. It's an energy hungry and expensive process, but after you've done that, the idea is that you use the geosequestration again. So it's carbon capture and storage. There are, I gather, about 15 plants operating around the world, mostly demo scale, but apparently there's one operating in Iceland that they say is commercial scale. So people are starting to do this. It costs a lot, but it's seen as very secure carbon storage. Once you've put it under the ground, it's pretty secure. The other one I've got illustrated there is enhanced weathering. This is a much lower tech process. The idea is you crush basalt very fine and spread it across the land or possibly in the ocean. And as it weathers, it takes CO2 out of the atmosphere. There's a range of other ways people are suggesting: fertilizing the ocean to make algae grow, putting logs into the ocean, let them sink to the ocean floor where there's no bugs and they won't decompose. That sounds like a waste of logs to me. And I'm hoping that we essentially won't need to go there. The IPCC's report on limiting warming to 1.5 degrees, we call it the SR 1.5, investigated various alternative ways to meet the target. And they're essentially based on global models that are fairly limited in their options for carbon dioxide removal. They tend to only have reforestation and BECCS, bioenergy with carbon capture and storage. But the point of this slide is to show that depending on how the world goes with its success in reducing emissions, we may need a little or a lot of carbon dioxide removal. So P1 is a pathway where all countries get on board, reduce emissions now. We don't need any BECCS and we only need a small amount of reforestation. At the other extreme, if we keep going with our current fossil fuel use, we will have a lot of emissions and therefore need to take a lot of CO2 out of the atmosphere. And what the IPCC found and what the models showed is that if you had this drastic scenario like P4, you could need up to 720 million hectares of energy crops in order to grow the biomass to do enough BECCS to do that much CDR. And that's half the arable land of the world. So not surprisingly, people are very concerned that this could happen, and they want to make sure that we reduce emissions now so that we don't need this much CDR, and that we find other ways to do CDR that will have less impact on food security, for example. Another recent report from the IPCC looked at that relationship between climate change and the land, and in particular the implications if we did do that much CDR associated with afforestation or BECCS. And it identified that very close relationship between climate change and land degradation. Much of the world, the ice-free surface is already degraded. The land's under pressure from unsustainable farming practices. Soil's being lost 100 times faster than it's being formed. And climate change is exacerbating this land degradation, increasing frequency of droughts, for example, the land bare and exposed to erosion.
Hey, George. Sit. No, sit. Sit.
I think somebody might need to mute their mic, please. Anyway, the good news is the very tight and close relationship between climate change and the land means that if we succeed in managing the land sustainably, we can improve the land quality at the same time as providing climate change mitigation. I've put there the definition of sustainable forest management, and this was quite important. This was the definition that we developed for the Climate Change and Land Report. And there was a bit of pushback because people who aren't foresters tend to think that sustainable land management and sustainable forest management must maximise carbon stock on the land. And we said, well, no, what we're trying to do is maximise the contribution of managed land to climate change mitigation. And that can involve maximising the wood products, for example, so that you have those other benefits that I described. And so therefore we have a definition here that says that sustainable forest management is management that maintains the productivity, that is the productive capacity of the land, its regeneration capacity, rather than maintaining maximum carbon stocks. The report identified that the three measures of afforestation, BECCS and biochar could have positive or negative effects on land and on food security, depending on how it's done. Certainly, if you were to wipe out a lot of high biodiversity value forests, this would have a negative impact on biodiversity. If you were to plant energy crops all over the current arable land, this would obviously impact food security. But the report identified that it can be done better. And that if you integrate trees with existing agricultural systems, you can provide environmental and production benefits. That could involve environmental plantings, farm forestry, short rotation woody crops for biomass, such as we're trialling that photo down the bottom right, Fabiano Ximenez trials of ukes for short rotation coppice. And they can be placed strategically in a landscape where you can provide shelter for livestock and crops, you can increase biodiversity, you can manage dryland salinity, you can reduce runoff and leaching of nutrients into waterways, you can stabilise slopes, manage erosion and protect riparian areas. So reforestation does feature strongly in national climate change policies. This map is showing all the countries that have committed to net zero targets, or at least are on the way to it. About 150 countries now. You probably noticed that Australia came on board rather late, just at the last minute before the Glasgow Climate COP last November, but we're there now. At the federal level, our focus is on technologies, as you'd be aware. But it wasn't all that difficult at federal level to adopt a net zero target because in fact all the states already have one, for net zero for 2050 or earlier. In New South Wales, we have a target of net zero by 2050 and we have a stage 1 target that was 35% reduction by 2030, but we've now increased that to 50% reduction by 2030. At the federal level, the main strategy for achieving our emissions reduction is the Emissions Reduction Fund. This is a voluntary scheme whereby the government uses taxpayers' money to pay landholders on the whole to take action that reduces emissions or sequesters carbon. Most of the project types that are available at the moment are relevant to the land sector. There are an increasing number of others coming in though. Carbon capture and storage, for example. This figure summarises the status after the 12th auction, which shows that by far the majority of projects have been in vegetation management. And they're concentrated in particular parts of the country. Way up north are the savanna burning projects. The blue are the human-induced regeneration projects. So this is basically taking land in the rangelands, which would naturally regrow what we commonly call invasive native scrub, and fencing it off, stopping grazing that land so that it regrows. There's also avoided deforestation, which was a short-term opportunity in the red dots. But in Western New South Wales, we actually have 8 million hectares apparently under carbon farming projects. We've looked into the potential for the primary industry sector to contribute to the New South Wales net zero target. And we looked at the range of different ways we can reduce agriculture sector emissions. By far the majority of emissions is the methane produced by livestock. And there are some promising strategies there. You've probably heard about the magic asparaginopsis, the red seaweed, that can reduce emissions by up to 90%, which is quite phenomenal. But it needs to be fed daily, so it's useful for feedlots and dairies, a bit of a problem for grazing animals, but they're working on how they might produce a slow release form. There's also 3-NOP, which is a chemical that's going through an approval process now, also very effective. What we found was that with the various measures we could reduce emissions, we are not going to get anywhere near net zero for the primary industries sector. But if we bring trees into the equation, certainly there's very large theoretical potential to reduce emissions and in fact to become negative in the primary industry sector, which is going to be important because the land sector is going to have to offset emissions from the other sectors that can't get to zero. Many jurisdictions are recognising the multiple benefits that can come from carbon farming projects that involve native vegetation, for example, and are giving extra credit or extra payments towards carbon projects that provide additional benefits for biodiversity, social or economic objectives. we don't have one in New South Wales. That applies in Queensland and Western Australia at the moment. At the industry level, there are a number of different initiatives for enhanced sustainability standards and schemes supporting the many companies that are trying to get accreditation for carbon neutrality or net zero. So those are some international schemes. Just speaking about carbon neutrality, it's worth reminding what we actually mean here. Carbon neutral is pretty similar to net zero, emissions equals removals. But when we talk about carbon neutral, we're usually talking about a calculation on a carbon footprint basis. So that's across the whole life cycle, including direct and also indirect emissions and removals. And usually when we're talking about carbon neutrality, we would allow for offsets in order to reach that, that zero position. So offsets are emissions reductions or carbon sequestration that's undertaken by somebody else. You pay for the credits. There's a hierarchy that's normally applied that says that first it's your responsibility to reduce your emissions and then undertake removals, carbon dioxide sequestration to the extent that you can. And finally, only then do you offset the residual emissions. You may have heard that Microsoft has pledged to offset all its emissions associated with its products they've ever produced, and they've undertaken purchases around the world. They've paid for carbon sequestration in forestry, mostly in the US. They've bought DAX credits from Iceland, this direct air carbon capture. They've bought they've bought biochar credits, including from Australia, and they've bought soil carbon credits from Australia. You may have heard about the Wilmot trade. Bit controversial, this concept of selling our emissions offshore, that it's been undertaken under a scheme that's not actually recognised at the federal level. And the latest agreement in Glasgow is that they need to make sure schemes such as this don't actually amount to double counting. Here in Australia, we have the Climate Active program, which is run by the Commonwealth Government, which gives carbon neutral certification for products, but also for organisations, individual events, individual buildings or whole precincts. The Armidale region is going for certification as a precinct. And at the industry level, we have targets such as MLA's carbon neutral 30 target. They're aiming to reach carbon neutrality in the red meat sector by 2030. Challenging, but as I said, there are some promising ways forward there. And finally, I've got the example of Jigsaw Farms in Victoria, which is carbon neutral. What they've done there, they're raising sheep and cattle. They've undertaken environmental plantings, and they've also put in woodlots, plantations of spotted gum to reach that situation of carbon neutrality. So I'm sorry if I've gone over time, but this is my last slide. I just wanted to urge you to promote managed forests as a climate change solution with multiple benefits. There's so much interest at the moment in net zero and amongst governments and companies. We need to promote managed forests as an opportunity to, as a natural climate solution that delivers multiple benefits for society and the environment. Thanks very much.